Hello everyone, welcome to Swag Talks. I'm Satvika from Second Cybersecurity and my partner is K. Lakshmi Kalyani. We are going to present on the topic of priority scheduling of topic operating systems. Under the guidance Dr. M. Prasad Sir, Associate Professor, Department of CSE. Now coming to the topic, priority scheduling is a scheduling algorithm used in operating systems to determine the order in which tasks or processes are executed on a computer's CPU. In priority scheduling, each process is assigned a priority and the CPU is allocated to the process with the highest priority. The goal is to give higher priority to processes that are more important or time sensitive. CPU allocates processor which is highest priority at first and goes on decreasing in priority levels so that the highest priority process is completed first and next the lowest priority. Here are some key points to understand about priority schedule. Priority levels. In a priority scheduling algorithm, each process is associated with a priority level. The priority level can be an integer with higher values indicating higher priority. So, this integer value represents the priority level of the given process or coming process that should be allocated to CPU. In that way, we can allocate the process to the CPU by checking the priority level of the process. Dynamic or static priority. Priority can be assigned either statically or dynamically. In a static approach, each process is assigned a fixed priority at a time of creation and does not change during its lifetime. That means if we allocate such a proper priority level, specific priority level to a process, it cannot change during its lifetime. Even though it wants to change, the priority level can't be changed until the process is to be terminated. In a dynamic approach, priorities may change as a process runs. For example, a process that is waiting for a long time may be assigned a higher priority to ensure it gets CPU time. In dynamic approach, we can change the priority of a process while runtime so that if the present process is less prioritized than the waiting process in the waiting queue, then we can change the priority of the waiting process to the highest and the lowest priority process will be added to the waiting queue and the highest priority process will be performed first. One potential issue with priority scheduling is starvation. Now let's know about starvation. If a process with a low priority never gets the CPU because higher priority processes keep arriving, it can effectively be starved, meaning it never gets a chance to execute. Means when we interrupt processes to the CPU, the process scheduler first sends the high priority process to the CPU so that lower priority process may be starved for a long time without being executed. This is called starvation. Priority inversion. Priority inversion can lead to situations known as priority inversion. This occurs when higher priority process waits for a resource held by a lower priority process. This issue can be mitigated using techniques like priority inheritance or priority ceiling protocols. Means if we need a resource for executing an high priority process and the resource which can be get from low priority process, so that this situation is called priority inversion. These techniques can be mitigated using techniques like priority inheritance or priority ceiling protocols. Next, real-time systems. Priority scheduling is commonly used in real-time operating systems where tasks have strict timing requirements. Real-time systems ensure that high-priority tasks are executed on time to meet deadlines. Just these real-time systems check and ensure that high-priority tasks are executed in time or not. That's it. And it uh, it has strict timing requirements. Next, types of process scheduling algorithms. There are two types: primitive process scheduling algorithm and non-primitive process scheduling algorithm. Coming to primitive process scheduling algorithm. A process scheduling algorithm is a type of process scheduling used in operating systems where a running process can be interrupted and moved out of the CPU, allowing another process with a high priority to run. Preemption is a key feature in primitive scheduling algorithms, enabling the operating system to respond quickly to changes in process priorities and system events. Preemptive scheduling is used when a process switches from the running state to the ready state or from the waiting state to the ready state. The resources are allocated to the process for a limited amount of time and then taken away, and the process is again placed back in the ready queue. If the process still has CPU burst time remaining, that process stays in the ready queue till it gets next chance to execute, or else it goes to terminate. Examples of primitive process scheduling algorithms. These are round robin, shortest remaining time first, priority, etc. Next, coming to non-primitive process scheduling algorithm. A non-primitive process scheduling algorithm, also known as a cooperative scheduling algorithm, is a type of process scheduling used in operating system where once a process starts executing, it continues to execute until it completes its execution, voluntarily yields the CPU, or enters a waiting state. That means when it needs resources from input-output devices, then only it goes to waiting state, or else it continues to execute until it completes its execution. Unlike primitive scheduling, in non-primitive scheduling, a running process cannot be forcibly interrupted before it finishes the execution. Non-primitive scheduling is used when a process terminates or process switches from running state to waiting state. In this scheduling, once the resources are allocated to a process, the process holds the CPU till it gets terminated or reaches a waiting state. In the case of non-preemptive scheduling, does not interrupt a process running CPU in the middle of the execution. Instead, it waits till the process completes its CPU burst time and then it can allocate the CPU to another process. Examples of non-preemptive scheduling are shortest job first, etc. Next, characteristics of priority scheduling. A CPU algorithm that schedules process based on priority. It used in operating system for performing batch processes. If two jobs having the same priority are ready for execution, it works on a first come and first serve process. Lower the number, higher the priority. Higher is the priority. In priority scheduling, a number is assigned to each process that indicates its priority level. In this type of scheduling algorithm, if a newer process arrives that is having a higher priority than the currently running process, then the currently running process is preempted. That means it goes to the ready queue and wait. These are the examples of primitive process scheduling and non-primitive process scheduling. In primitive process scheduling, it follows the first come first serve process in specific time limit, and it is based on arrival time. Next, non-primitive process scheduling. It is completed till the CPU burst time is completed. It should be goes on executing. Next, advantages of process scheduling algorithms. Provides better responsiveness. Priority scheduling allows high priority tasks to be executed quickly, ensuring the important tasks get timely access to the CPU. This leads to better system responsiveness for critical processes and real-time applications. Meet specific system requirements. It is ideal for systems with a mix of different types of processes with varying levels of importance. Critical tasks can be assigned high priorities while less critical ones can have low priorities. Those are easy to use. Processes with high priority execute first, which saves time. And also, it should be executed first so that CPU runs fast. The importance of each process is precisely defined. A good algorithm for applications with fluctuating time and resource requirements. Now let's see disadvantages of priority scheduling. Starvation. A major drawback of priority scheduling is the possibility of low priority tasks being constantly preempted by high priority tasks, leading to starvation. Low priority tasks may never get chance to execute, which can be detrimental in some scenarios. Priority inversion. In cases where high priority tasks are dependent on low priority tasks, example through resource sharing or input output resources, etc. Priority inversion can occur. This can lead to inefficient resource utilization and delayed execution of high priority tasks. We can lose all the priority processes if the system crashes. This process can use starvation if high priority process take too much CPU time. There is a chance that a process can't run even when it is ready, as some other processes is running currently. These are the advantages and disadvantages of priority scheduling algorithms. Thank you. Thank you everyone.